Hello everyone and welcome to the first part of the basic introduction to Wolfram SystemModeler that we will be going over today. From John, you have already learned how SystemModeler can be used in various different ways and what it can be used for. Now we will jump right on to seeing how we can actually use the software. My name is Patrik Ekenberg and I will be going over this in 3 parts. And you'll learn how to get started with Wolfram SystemModeler. Between each part we will open it up to questions. But however, feel free to type any questions you might have into the chat window and we will also try and answer them as they come up. This notebook that I have here will be distributed in the chat window, so you can download it for yourself and follow along with the tutorial. In this first part we will introduce ourselves with the software. We'll look at ready-made models that are runnable examples that are available in SystemModeler, and we'll find out how we can explore them. We will also simulate the example model and manipulate it in different ways. I will start by jumping into a new session of SystemModeler. When you open up SystemModeler for the first time, you will be greeted with a welcome screen. If the welcome screen does not appear, you can manually open it by going to Help and selecting Welcome Screen from the toolbar. From here you have direct access to different videos to get you independently started with SystemModeler. The 1 to 2 minute videos, modeling, simulation and analysis will give you the fastest possible introduction to SystemModeler. From here you are also able to see the latest features, go to the documentation center, find ready-made models and examples, and find more resources such as this training course. First, head into the documentation center by clicking the documentation icon. The Wolfram SystemModeler documentation center provides you with a manual describing the different parts of SystemModeler. Under Getting Started, you can find text-driven tutorials with step-by-step instructions ranging from how to set up the software to how to create advanced systems of models. Here you will also find documentation for the different sub-libraries available in SystemModeler. After exploring the documentation center, you can go ahead and close both this window and the welcome screen. You will now explore the modeling environment of SystemModeler called Model Center. When starting up SystemModeler, a blank diagram will be displayed in the middle of the window. This is the canvas on which models will be created. Surrounding the diagram, different toolbars and browsers will help you create models. For this tutorial, we'll be using a scale-down interface. In the toolbar, go to View, Window Layout and select Modeler. This will remove several toolbars we won't be using here. You can switch between different layouts at any time. In Model Center, you'll find the class browser to the left. Here you can find ready-made example models under the Examples tab. You will also find pre-built parts for you to use when modeling systems. These are found in the packages listed in the Library tab. Click the arrow next to a package to open it up and explore it further. The education examples and industry example packages contain complete models from different educational and industrial domains. In this tutorial, we'll explore a model from the introductory example packages. Click the arrow next to it and locate the inverted pendulum model under the Systems subpackage. Double-click the inverted pendulum model to open it. The model will be opened in the diagram view of SystemModeler. You can see here that the diagram consists of 4 different components: a controller, a motor, a pinion and a pendulum. Between the components are also connection lines. The gray and green connection lines indicate physical connections. The shaft of the motor forms a solid connection to the rotational part of the pinion, while the translational part forms a solid connection to the cart of the inverted pendulum. The blue connection lines form directional signal connections. The direction of the signals are indicated by the arrow at the base of the connection. Components are instances of other models, and they can themselves contain components. To explore a model behind a component, you can double-click it to enter it. Explore the motor component in this way. Inside the motor component, you'll see a new type of connection line, a light blue, indicating an electrical connection. On the far left, a variable voltage source determines the voltage over the circuit. In the main model, the signal determining the voltage was connected to controller. On the far right, an electromotoric force component converts an electrical current into a torque. When you have finished exploring the submodel, you can exit it by clicking the up arrow icon. It is now time to simulate the inverted pendulum model. To simulate the model, simply press the play button in the toolbar. This will automatically both build and simulate your model. The model will be sent to the simulation environment of SystemModeler, called Simulation Center. When running a ready-made model, one or more plots will be directly shown in the plot window. This is known as a default stored plot, and it will be displayed immediately after the model has been simulated. The stored plots are predefined plot setups that indicate the most important variables to explore in a model. Stored plots are listed in the Stored Plot menu on the left-hand side of Simulation Center. Bold entries indicate a default stored plot. Besides the variables found in stored plots, you can access all variables in the model from the Plot tab. The variables are sorted under the different components and subcomponent names. You can expand a component by clicking the small arrow next to it. Add a plot of the torque produced by the motor. To do this, you first need to add an empty plot. You can either choose to add a subplot to the existing plot tab, or add a completely new plot tab. Try adding a new subplot by clicking the corresponding button in the toolbar. Next, find the torque variable of the motor component by expanding motor, EMF1, and flange in turn. With the new empty plot selected, check the box next to the tau variable. The variable will be plotted in the selected plot window. For 3D mechanical systems, an animation of the simulation is automatically created. To access this animation, press the animation button in the toolbar. You can navigate in the 3D environment by holding and dragging the mouse pointer. You can traverse it by holding the Control key while dragging the mouse pointer. And use the scroll wheel on your mouse to zoom in and out. Press the play button to start the animation. During animation, a line will be displayed in the plots, indicating the current plot time. You have additional controls such as stopping the simulation, toggling it to repeat infinitely, and selecting the time scale. Click the blue part of the pendulum in the 3D animation window, and the corresponding component will open up in the Plot tab of Simulation Center. Create a parametric plot of the X and Y position of the pendulum tip. To do this, create a blank parametric plot window by clicking the corresponding button in the toolbar. With the pendulum cylinder opened, expand the frame translation component, followed by frame B. Then, in order, select the R01 variable, which corresponds to the tip's X position, followed by R_02, which is the Y position. To test a new set of parameters, switch from the Plot tab to the Parameters tab. Change the value of the motor resistance by expanding Motor and navigating to the field that is labeled R. Type in 4.8. Then resimulate the model by clicking the play button. Notice how the plot changes shape. Often it is of interest to compare two or more sets of parameters to each other. In Simulation Center, you can do this by duplicating an experiment. Right-click the inverted pendulum in the experiment browser and select Duplicate. You now have two copies of the inverted pendulum experiment. The second copy has not been simulated yet. Before running the experiment, switch back to the Parameters view and expand the motor component. Notice that the R parameter is displayed in bold and the return arrow next to the input field. This indicates that the parameter has been changed with respect to the value in the model. Click the return arrow to reset it to the model definition. Now go ahead and simulate the duplicated experiment by pressing the play button. The default plot angle and position for the second simulation will open up in a new tab. Compare the old experiment to the new one. Switch to the parametric plot that you created previously by selecting the corresponding tab. In the experiment browser, you will see a list of suggested plot variables. These correspond to recently plotted variables. Click the first and the second suggested plot variable in order, and the parametric plot will appear in the plot window. In the next tutorial, we'll learn how to create a model from scratch using drag and drop. Before we open it up to questions, let me quickly recap what we just did. We explored some different parts of Model Center and Simulation Center by looking at an included example model. We looked at things such as the Documentation Center, how to access model diagrams, and how to explore components of a model. Then we started a simulation of the model and plotted various variables from that simulation, and also viewed an animation of the system. So with that, let's open it up to questions. So if you have any questions so far, now is the time to ask them. Thank you.